think we ought to work on a radio today? Or is it time to go to sleep? Willow, do you want to help with the radio today? Would you like to go outside and work with Daddy on a radio? Look at me. Willow just got back from the groomers. So she's really tired. It's been a rough day getting a bath and getting all blown. She's a big helper with me on my old radios. She likes to hang out with Dad while he's out there working. All right, go back to bed. Well, good morning. This is John from Indiana, and I would love to welcome you to a new video. What I'm going to be doing on this video is going to be going a little bit into depth for this series, and I'm going to be using the $10 radio that we have behind us here. This $10 radio is one that I'm not going to refurbish because it's in such a bad way. I'm going to probably use it for parts, but I just want to use it because I've been on the internet trying to find the one that I'm going to use in this series, and it's been a little bit of a work because I find some good ones, but they're like several hundred miles away. And so I'm waiting for one a little bit closer. But until then, there's a lot we can do with this $10 radio, and because it's a Zenith radio and it has the open bottom. So we're going to take just a few minutes and go through that. It might take a little bit longer than a few minutes, but I want you to go and see where the parts are located on that radio, and that will help to familiarize you with that Zenith radio. And a lot of the radios are exactly the same. The parts might be a little bit different spot on the top, but it will be something that you'll be able to reference. Okay, that's a transformer, that's something else, that's a tuning capacitor, and you'll be able to kind of get a familiarization with the parts. We're going to go into depth as we go through my radio, but on this particular radio, it'll kind of give you just a rough idea. And like I say, don't worry about, oh, I didn't get that, because it's going to be coming up step by step. We're going to go through that other radio. So I tell you, I told you we're going to select it, and then we're going to go get it, and then we're going to show you how to get it out of the cabinet. We're going to bring it in, we're going to break it down. So it won't be that hard, and we'll get you to where you feel really comfortable about dealing with these old radios. I hope you enjoy this video today, and I'll see you at the end of the video. Thank you. Okay, as promised, this is our display radio. This is not the actual one we'll be restoring, but this is the one we talk about in the intro. The $10 Zenith Marketplace radio. This is the copper chassis type. I just wanted to take a few minutes and go over the different parts so you can start to get familiar with when you look at one of these radios or what you're looking at. Over here on this side, this is your main transformer. Your main transformer, if you look at the underside of this, this is what provides you your power. And your main transformer will come in, and you'll see all the wires coming in from the underneath side right here. When we actually get into the radio itself, I'll go over what each of these wires do, but I'm going to give you a quick overview. You don't have to remember them all right now. But when you see the heavier, thicker wires like these right here, you know pretty much that these are your filament type wires, the wires that will carry your filament voltage. That's actually lower voltage but higher amperage. I pointed to the wrong ones. It's these right here. That's your filament wires, and that's going to provide that voltage to that rectifier tube. Most of these operate on 5 volts, and when you see low voltage like that, you think, wow, I can't get shocked on that. But when you have low voltage, it's going to carry high amps, so you want to be real careful around these thicker wires like that. Then you should have another set of wires that are a little bit thicker that run out to the other tubes for their filaments, and that's probably, I can't tell, but anyway, we'll trace those when we actually get into it. But there'll be two sets of wires that are thicker, the two that go to the rectifier and the two that go to all the other tubes in the radio for the 6.3 volts. But usually your rectifier runs on 5 volt. All right, and then you have your primary wire where your cord comes in, where it plugs into the radio for the actual voltage going into the radio. And that'll be your primary. So you have those two sets of wires, and then you'll have another set of usually 3 wires, and that's what will be coming out here, and that'll be for your high voltage AC that comes over to the other side of the rectifier. You'll have one on each side for the plate, and then you'll also have one that actually goes to the center tap. So you have your both sides of that transformer, that winding on there. And later on I will pull a schematic alongside of this, and I'll show you how all those work. But right now I'm just giving you a quick overview. So you should see about 8 or 9 wires, depending on what you got. If you don't have a center tap, well, sometimes transformers don't have them, but most of the time you will on these Zenith types. You'll have a center tap on your high windings, on your high voltage on the AC. All right, I will explain all this in detail when we actually get to it, but I just want you to know that's kind of what you're looking for on a transformer. You want to make sure, and we'll go over what we do with that in the end. All right, the next thing you want to know, you know your transformer now, and that's why I told you get a set with a transformer on it. The second thing is when you see a silver can like this is your electrolytic. An electrolytic, or they call them filter caps, basically what they do is they filter out the noise. They filter out, like when you turn the radio on, and you're not supposed to turn the radio on before you test it, but when you turn it on, say you plug one in, I want you to hear this loud hum, that's what's going bad, this filter cap right here. Usually there's more than one on a Zenith. There's like 2 or 3 of these, but they're real tall, shiny silver. Some of them are way taller than this and way bigger around than this. The point I wanted to show here, and I'll go into detail on this when we actually get into the radio, but this has more than one filter cap inside of it, and you can tell how many is inside of that because most of them have printed on the side right here. See, this one says a 20 at 450. There's another 20 at 350. And then there's another 20 at 350. So this is 20 microfarad at 450 volts, and then you have 2 20 microfarads at 350. So there's 3 caps inside this, and then you also have a ground. A lot of times the cap itself will be directly connected to the chassis, which gives you your ground. So the caps go in, and then they come out through the frame on the cap itself to ground. Sometimes it's a floating ground that goes elsewhere and meets up with other things, and then they all go to ground together. And if you can tell that because there'll be a phenolic washer in between here, and it won't let this cap directly ground right away, and it'll follow another wire off of here that goes somewhere, and it will eventually ground. But these are the electrolytics. And these are also called filter caps, if you hear people refer to them as that. You, like I say, you'll have either 1, 2, or 3 of those, but they look different than everything else because they're real tall. Most of them are that bright, shiny silver look, but there are ones that are different too. They are more obscure, but they're shaped like that, tall, round, and skinny. And that's going to be your filter caps. Okay. The next thing that you'll end up learning how to use, and I'll go into depth on this whenever I get to these, but these are called your IF cans, or intermediate frequency cans. These cans right here are what help your actual frequency go through the radio, and it simplifies that frequency. And I'll explain that in depth. I'll even show you a little picture. I'll draw you a picture of how these work. But basically, I'm going to just give you a quick statement. Whatever frequency you dial in on the radio, it gets converted to just one frequency, and then it follows through the center part of that radio all the way through the middle of part of that radio. Then it'll follow that one frequency, and no matter what you dial in on the beginning, it will follow, and it'll follow whatever frequency these are set at, and it'll ride along with that. And then at the end, right before the output stage, it'll dump that, and all you'll have left is your radio frequency, your audio port, your RF part. But the nice part about this is it simplifies. The radio doesn't have to try to figure out what frequency you're on or anything, because all it sees is the frequency of these two things. Sometimes there'll be more than two, sometimes there'll only be one. They should be one through, the most I've seen is 3. I'm sure there might be some with 4. But these are just basically tuning stages, and it's called IF cans, or intermediate frequency cans. Now, how you tune these, they're also set at the very low end of the dial because you don't want a lot of interference and a lot of noise. So a lot of these are 455 kilohertz or 456 kilohertz, but they're down at the very bottom end of the broadcast band. And how you tune them is these two little screws on top, and you see the two over here. The 2 screws on top is how you tune them, and I'll go into that full thing when we get toward the tail end of our radio restoration. Also, another part on here is this, and this is your tuning capacitor, and you have different sections on the tuning capacitor. I'm not going to go into that now, but you have all of these. They are slaved to go together. Now this one's got a broken dial band, so I'm having to manually turn it. But basically you have 2 parts to it. You have the rotational part. These are blades that go inside each other. These are the stationary part. They don't move, the ones right here. But the ones here, they turn inside out, inside of the ones that don't move, and that's how you dial in your radio station if you want. And one's called a rotor because it rotates, and the other one's called a stator because it stays. And that's the easiest way to remember those. And then you have, like, a lot of radios have it where you can adjust all 3 of these, but this particular radio only has one area that you can adjust, and that's part of the alignment procedure, which you'll learn later. But you do have different sections. Sometimes you have multiples of these, but when you turn one, you're turning them all on this one here, because it's all slaved together. But one of these is for your oscillator, one of them's for your antenna, and then the other one's for your RF. But I'll go into those kind of things later on and kind of explain that in better. This is just a quick overview. And then just so you kind of identify parts on the top of the chassis. Then sometimes you'll have multiples of these, but you'll have inside these boxes that just have this single hole in the middle, and sometimes they do have different holes, but they won't be like these that have the screw holes on the top. But these are coils, and more than likely this one's the oscillator coil. I'm doing this from the blind because I've never really worked on this model, but this one's probably an oscillator coil. But you have an antenna coil and you have others. Now this antenna coil for this one might be underneath and not inside a can like this. But more than likely, because it's where it's at, it's probably an oscillator coil. And basically you can tune. And what an oscillator does is tune you to the right. Like say if your dial says you're at 1400 and when you tune 1400 in, sometimes your dial will be at 1600. Well, this helps you to tune that in to where you can get your, well, actually when you're trying to get a radio station, and like around this area, Fort Wayne is I think 1290. Well, there's a lot of radios I pull up and I'm getting Fort Wayne on 1100 or something like that. Well, you can dial in the oscillator and put that on the right thing, so when you dial in Fort Wayne, you're actually seeing 1290 on your radio dial. So that's kind of what that thing does for you. Then the rest of these are all tubes on the top of this one. It's pretty simple version of this. Few things to watch out for safety is, once again, these lights operate, most of these operate at 6.3 volts, at least on these Zenith chassis. And when you have low voltage, you have high amps. So you don't want to be laying your hands all over this stuff, because you can get shocked pretty bad on this. Other places to get shocked on here is, if I can get it out here. Now this has been cut off. They shouldn't have done that, but this radio somebody cannibalized really bad, but that's why I can't restore it, but I'm gonna use it for parts. This is your plug going out to your speaker, and there's high voltage. This is where, when you hear somebody referring to B+, this is your high DC voltage coming out here, and it goes out to the speaker. You can get shocked, like if there's any frayed wires or whatever right here, or if you got the plug out a little bit. There's sometimes, 300 some volts going out here, and you don't want to put your hand too much around this. If you ever mess with any high voltage, they have a rule, and you're going to hear this from me all the time: put your hand in your pocket. You put one hand in your pocket and one hand working on the radio, and that's to keep the voltage from jumping across your body, going through one hand, through your heart, and back out the other hand. So you keep one hand, anytime you have power applied, one hand in the pocket, and that'll save you from getting a real bad shock. I mean, you still could get shocked, but at least it won't kill you. When voltage passes through your heart, sometimes it can be deadly. All right, the next thing is this little plug right here. This plug is going out to your antenna, and then this plug is going out to your power. This is like your line cord coming in from the wall. And then these are your where you hook your antenna on. You hook your antenna onto there, and your ground onto this one. And then there's sometimes when you can interlock these two. I'll explain the Z later on. I'm not going to mess with that right now, confuse everybody. Then you have, if you see these little holes with and we're not going to go into depth with that right now, but these little holes with the little screw head inside of it, these are adjustments to use when you actually do an alignment. It takes you through the steps and tells you where to go to get that, and I'll show you all about how to do that. Just a quick tour underneath. Get me? Now, this is what I was talking about on the Zenith chassis. Look how much room I got to get all my hands down in here. When you're learning, this is the kind of chassis you need, because you can reach everything. And it makes it real simple for somebody learning. You don't have to worry about, okay, what do? I don't know how to get underneath that. Well, this makes it real simple, because you can I can lay my whole hand down in here. I'm clear at the bottom. Even underneath the switch, you can get all the way up underneath these over here. You can reach your hand clear underneath there to get to the like that cap right there. It's real easy to get to. Everything is handy, and that's what you want. That's exactly what you want. There is so much underneath here. When we actually get into I've been hunting on Marketplace to try to get the right one for this series, but it'll come up. I found some good ones. I found a $20 one that was definitely worth the money, but I would have to drive 250 miles to go get it, and I'm not that motivated to go get that. I'll wait. They come on every day, and I'll wait for the right one that's maybe 60 or 70 miles from me instead of that far. But these are things that we're all going to learn together, and I think it'll be so much fun to show you how to do this. You've heard me mention, I think, in one of the intros about the Candohm resistor. This is a Candohm resistor, and they all look a lot alike. The bad part about these is because as they age, these are multiple resistors in a line, and they're all interconnected end to end. Okay. And this one has two resistors, because you can tell how many tabs it's got. So it's got a resistor between here and here, and a resistor between here and here. So this one's got two, but most of the time, not most of the time, a lot of the time, these are burnt out because this stuff deteriorates in the middle. And I'll break one of these apart and show you what the inside looks like. But basically, you'd be surprised that, a lot of them just like paper and foil with electrolytic in between, but it's amazing. But this stuff deteriorates and these break. I can show you on this one, like you can just push on that a little. Well, this one's better shape than I thought, but this stuff just it breaks like crazy. Okay, and they go bad. And there's ways to fix that, ways around that. But if you hear somebody reference a Candohm resistor, it just means there's multiple resistors in series in a length. And what these things do is they provide bias to the tubes. And I'll explain how all that works when we get into our radio. But it provides a bias because each tube has to have a bias to operate properly. And it operates that, and it also gives other voltages sometimes in there that you need. But it works from the highest end to the lowest end. So the highest end, and then the lowest end will be on ground. So it works from high voltage right here. And when you hear people say B+, I'm going to say this 1,000 times, B+, all that means is high voltage. When you see B+, and most of the time they're referring to high DC voltage on that. But when that B+, it works its way down this resistor and gets reduced as it goes down until it hits ground and reduces to 0. So it works its way down. And some of these Candohms have multiple ports. They'll have like 6, 7, 8 ports. This one only has 2, which makes that real simple too. But you got to make sure that's working, because your radio is not going to work unless this is working. And we'll show you how to get around, like if this is open between here and here, or something wrong between here and here, there's ways of fixing all that. All right. When we get into the radio, these are what they call, these ones that look like that, they literally have wax on them. You see that on the end of my finger. That's wax. It's like kind of like candle wax. But boy, I ran that up in my finger. Okay, but anyway, these every one of them, you can just, you could probably go through and find a couple good ones. Replace them all. They all got to go. So every one of these, they call them waxies. These wax capacitors need to go. Now there's some of them that are critical and some of them that are not. Some of them go between tubes and they're very critical, and then there's some in some areas that are not so critical, and you could probably get by without not changing them. But to me, no more than it costs for a capacitor like that. Change every one of them, and that way you don't mess up, and you're going to have you a nice dependable radio for a long time. Most of these radios, when you get underneath, they're going to be full of mouse houses, spider webs, bugs, everything. So you're going to blow these out before you actually bring them inside your house, because I've seen them completely packed with newspaper and stuff where the mouse has built their thing. And I'm going to tell you something else about mice, is they love to eat these wires. These are cloth covered wires right here. Well, that one's a rubber one. You can see what happens when rubber gets old. See, they crumble and break to nothing. But they like this one's a cloth covered wire, and the mice love to eat those. They will chew that wire wide open, and then you got a bunch of bare wires in here. So you definitely got to replace all these rubber ones. If you see a rubber one, well, if you touch it and it does that, put a new wire in, because it'd be stupid not to, because you could have a chance of that shorting against the chassis, and that definitely would be an issue. Okay, this is just a flywheel. I'll get you on this picture. This is just a flywheel, and what that does is just help have more freedom in the movement. It gives it a nice movement when you're tuning the station out there. A lot of times on these old radios, somebody put a rubber thing on here, and I know people tout these and say, oh, they're awesome, and that's what they're selling on replacement ones on eBay. I don't know. There's times you need them and times you don't, but they tend to stretch and slip on you real bad. But they're good for a few minutes. But I tend to find, I know everybody's against the old cement belts. They kind of look like a little leather belt. But if you find, there's still a lot of good new old stock ones out there that are not all dry rotted. They dry rot out. That's why everybody don't like them. But I got a hold of a couple batches of really good ones, and they're like new. And I'd rather use them than the rubber thing, only because these things, they see how much they can stretch, and they get loose, and then this will slide on there. That's why I don't like them. But we'll get into that another time. This is your switch right here. This is where you change between bands. It should go to a knob out front here. And when you rotate your bands, you can go from a broadcast band to a shortwave band to a police band, and you know, sometimes you have multiple bands on there that you can go to. And that's what this rotates through, and it goes through these little wafers that has tons of little wires all over it, and it all does different things, and they all interconnect with each other. And it's best, especially starting out, hoping that you have nothing major wrong here, because it's very hard for somebody starting out to understand how all this works, because you have to understand the schematics really well to understand how this thing works. Because when you turn one, you're changing, there's a wafer here, and a wafer here, and a wafer at the back, and it works on both sides of the wafer too. There's switches on both sides of the wafers. So you got 2, 4, 6 faces of that switch, and when you turn the knob out there, you're affecting all 3 of those on both sides, because it changes something in each one of them. So you know, you have to be real careful when you mess around with the switch. But that's what that does underneath here. That's a switch assembly. And then we talked about the antenna coil. And off the end, I'm going to get you out here on the end a little bit more. All right. Anyway, on your antenna coil, that little hole that was on, I think we saw one on the back. But the one over here on this side, there's a hole, and it has an adjustment screw for the antenna coil. So when it comes in, you can fine tune that antenna, and that's part of the alignment procedure. And there's another, I'm pointing at the wrong thing, but it's right there beside of it, the adjustment of it, this thing. So that's part of the alignment procedure, and you'll learn how to do that kind of stuff later on. Really, in a nutshell, this is pretty much it. This is your switch for your on and off. As you can see, it's coming right off the transformer over there that we talked about, and it goes up the switch and then back out. And so this is what turns the radio on and off, and it probably on this particular radio handles the volume control too, because the switch is on the back side of it, and then the volume control part is in the front here. So you're handling more than one thing when you mess with this, and it's probably this small thing on the tip out there. I'm up here messing with it and don't even have you in camera. It's probably that part to turn it on and off. I haven't checked this radio out, so I don't know, but it does multiple things in that switch. But that's what that's for. So it not only does, this column not only does your tuning, but it does your power on and off, and it does your volume. Because I don't see any other volume controls on here. But anytime you see one of these little guys that's over here, these are all adjustments, all fine-tuning adjustments that you'll learn in your alignment. A lot of times, and I don't know if that's the case in this one, but this adjustment back here, and it more than likely is what they call wave trap, because those IF cans that we looked at on top, those IF cans have to be set around 455, 456. And what you can do with this and this may not be the wave trap, but they call it a wave trap, where you can block any signals coming in through your antenna, that you can block any signals that are around 455, 456, just in case there is some kind of station broadcast in there, and it blocks that. You can tune this to that 455, 456, and anything coming through with that signal is going to get blocked, not be allowed into the radio, because it'll interfere with your IF cans. So that's a pretty cool little thing called a wave trap. There's a lot of other stuff that we will get into when you actually start doing the radio, but that's just a quick overview of all the parts on the chassis. So, of course, this is the front. I told you about changing the switch. This is the part to change the switch. So this thing has 3 knobs. One for the switch, one for the tuning, and one for the on and off and volume. So there'll be a knob here, a bigger knob here, and a bigger knob down here. So you have 3 on this one. And basically, when this thing rotates up and down, that changes your switch, and you can see it rotating in the. You can't if I don't put it on there, but you can see it rotating in the little things right here, and you know where you're at. so it tells you what switch you're on. That's pretty cool. And then this has got the square face. There's some fancy ones that have. I hope I find. That's why I'm hoping I find one like the other one. But I'm gonna put that back this way. I hope I find one that has the shutter dial and the other kind of stuff to just give you that extra little bit. All right. Well, I think I'm gonna end this right here, and hopefully this will be something that helps you a little bit. Transformer, electrolytics or filter capacitor, tuning capacitor. These are the IF cans. There's 2 of them on this radio. That's the oscillator coil, and then the rest of this is all, everywhere else is just tubes. And this is, and I'm going to just give you one little tidbit. It took me a while to figure this out, but the more tubes, the more valuable the Zenith is. So if you see a lot of tubes, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a 10 tube Zenith radio. Now, like I say, what makes this Zenith, I don't know why, but I think it's just because it is so much work, but the ones with push buttons are not as valuable as the other ones. This is a 10 tube, which would, my first thought would be, okay, it's maybe got a little value to it, $200 or $300 probably. And this one may if you had it fully restored. But you're going to spend a lot of money on getting it restored. If you kind of need to know, you're going to have probably $100 in getting it restored yourself, even doing it yourself, probably close to it. And you can't really charge the customer for the time. You can charge them some, but you're not going to get what you have in it. I promise you. I spend a lot of hours in these old girls, and I've had some radios I've had over 100 hours in, and you're never going to get that time back. But what are we doing? If you really love this hobby, you realize that that's not the important part. The important part is taking one of these and making it last another 80 years. Some of these are 80 to 100 years old, if you get into the older ones. And to give it life again, there's a feeling I can't explain. And I've been doing a lot of them, and I don't get over it. So anyway, I'm going to use this for more examples while I'm waiting to find the radio to get started on. But we're going to use it for trying to study a little bit on basics on how to look at a schematic, and we're going to match the schematic, the symbols, and look at it. Not detail schematic, because I want to do a section on that too, but I'm talking about to match, okay, what does an IF can look like on a schematic? What does a transformer look like? What does electrolytics look like? Because you have to know that to be able to refer back and forth, so you know when you start tracing. So that's probably what my next video is going to be. I'm going to still use this chassis, and I'm going to find what model number this is, and we're going to pull up a schematic, and I'm going to just show you, okay, where's the transformer? It's right here. And I think that's what I'm going to do next. That'd be kind of fun. And hopefully we'll run across my radio here soon. But if you have any questions, make sure you post your questions, and then I'll try my best. Like I say, I work a full-time job, but I'll try my best to at least read it and hopefully maybe answer in general, even if I have to do it in the next video or something. But please like and subscribe if you're going to enjoy this, and I hope you do. We'd love to have you aboard, and I guess I'll see you in the next one. Well, I hope you enjoyed that. That was about 30 minutes of your time, and I hope it wasn't wasted time. I hope it'll get you started on that. Like I say, our next video, we're going to go over how the schematics relate to those parts you just saw, and we'll take just a short, like I say, I'll go into depth later on, but I'm just going to quick overview using this old $10 radio. So I hope you enjoyed this, and I hope that you will field any questions you may have. I'll try to get to them as soon as I can. All right, thank you very much.